And this is MCT4C day 11. The lesson is 2.1 graphs of sinusoidal functions. Its 3-minute review goal is to state the primary trig ratio of multiples of special angles. We're reviewing all this business from last chapter again. You see I've built my chart there. This is the way I like to memorize it. You could use the triangles. I'm going to remind you real quick how I come up with the table. We remember that sine starts at 0 and goes to 1, and then we go halfway between. This should say a half. Halfway between 0 and a half is a quarter. Halfway between a half and 1 is 3/4, but then we take the square root of all the parts. Square root of 0, 0, square root, square root, square root, square root, square root. And we get the square root of all that, and these are the right values. Cosine is in the opposite direction. Tangent is just sine divided by cos. Opposite divided by adjacent is tangent, and those are the numbers. And so if you can come up with tables, most of these are pretty easy. Sine of 30 is a half. Cos of 45 is cos of 45, 1 over the square root of 2. And then when we have one like this, one that's not on our chart, well, we'll draw a little diagram, but it shouldn't be too bad. 240, where is it? Well, rotation angle to there would be 180. We got 60 more, right? So this angle here is 240. And then I know the related acute angle is 60. So as soon as I know the related acute angle, I know that I'm talking about this line in my chart. Since it's the sine, I'm thinking that it's that value. But the only thing that I need to worry about then is whether it's positive or negative, and how I do that is using the cast rule, right? Since we're in the third quadrant and only the tangent is positive in the third quadrant, the sine must be negative. Today's lesson is a bit strange because really you've got a bunch of work to do before you come back and see some examples or come back. You do the 3-minute review, which you've done. And then there's 3 handouts. There's the graphing y equals sine x cos x, and there's the Venn diagram handout, and the Freyer model handout. These will all be done in class. So if you have trouble with them, you can ask in class. I'll take them up very quickly in this video, but then we'll come back to do the video after. Okay, so this is a bit of a strange one because this will all be done in class with your classmates and with me helping. Okay, so you should pause, do the stuff in class, and I'm going to take up the stuff that you were supposed to do and also do the examples after. There's the note, there's the things that I asked you to do, and here are my versions, actually sort of my versions. There's that handout, should look like that. Fill the table out just from our special angles, and if you had trouble with that, you should have asked in class, and you can still do that, of course. One thing I want to mention is if I'm asked to graph y equals sine x, do I have to remember this whole table? The answer is no. Just important values, right? These in-between values, who really cares? We want to just be able to get a nice sine curve, a nice, nice smooth wave. And these values are enough for us to do that. So these are the values we kind of have to memorize. And I'll talk about that in a minute. So the cosine, you should look like that. Again, these are just special angles, and you're coming up with a special angle. Sometimes it's negative. But then you plotted the points where the input were the angles and the output were those special ratios, in this case the cosine. We can see the special values there. On this page, I also gave you a chance to practice some on your own. And hopefully you didn't have to reproduce all 13 or 20 points or whatever the heck that is on these ones. Just these important points. So for instance, if I asked you to graph y equals sine x, you know that it goes through these values, right? These important values. And these important values are in a pattern. Every 90 degrees. Important points every 90 degrees. Important points every 90, right? And so for sine x, you kind of have to remember it starts at 0, then an important point every 90. It goes 0, then high, 0, then low, 0, then high. And I just follow this pattern. I can follow this pattern in both directions. Nice smooth curve between all the points. Shouldn't look like teeth. It should look like a nice smooth curve, a nice wave function, and then so on. These grids were there for you to try some more. And then the next exercise where you helped you compare the two, which is the Venn diagram exercise. It looks something like this. Some of you might actually use this file in class to do your exercise. Venn diagram or circles, and so this area would represent characteristics only on sine, both just cos. So y-intercept of 1, well, which of these graphs have a y-intercept of 1, or maybe both? No, just the cosine. So that one would go there, this one would go there, and so on. My version, don't cheat now, try it yourself, but it's right there. Check your answer. And then you use this value to fill out the next handout, which is the Freyer model. The Freyer model is this handout. And notice I listed zeros both in just their x-coordinate and the points themselves, right? Zeros are when the output is 0. The period, remember, is how long it takes for the graph to start repeating itself. So the cos graph starts high. How long till it's high again? Well, it's gone 360 degrees in the direction of x before it starts repeating itself. That's what the period means for a trig function. That one was cos that I saw, but the period of sine and cos are actually the same, aren't they? You see some of the values there. Fix yours up if you need to. And now I'm on to back to the note, which is a bit of a thing here. It says, recall in the unit circle, the coordinates of the point px, y, where the terminal arm of angle theta crosses the unit circle is given by blank. Well, what are we talking about here? Remember, and I'm going to use 30 as my example. It's the first one here. Right here, this point. If this is the unit circle, right, this is the unit circle, the hypotenuse is 1, then the x-coordinate, which is this amount down here, well, that's the adjacent side, and the hypotenuse is 1. The x-coordinate is the cosine, right? We've saw this a lot last chapter, but it's coming up again. Then if we think of it this way, we can fill in this unit circle along with our special angles. So this one here, for instance, the cosine of 30 was square root of 3 over 2, and the sine, the y-coordinate, was a half, and I can go through here and quickly fill these out, either off my table, or I could think about it a bit, I guess. X-coordinate and y-coordinate. Now the special angles this is pretty neat way to remember it. For instance, this point there, well, what's its coordinates? It's 1, 0. So what does that mean? It means for an input of 0 degrees, the cosine, the x-coordinate, is 1. So the cos of 0 is 1. The sine of 0 is 0. And we saw that on our graphs again, didn't we? And then I'm going to keep going. This is 0, 1. Cosine's 1. And notice there's the first part of our graphs. The cosine graph starts at 1, then goes down to 0. The sine starts at 0, goes up to 1, but now I can continue according to the cast rule, and I can see this on my grid. The x-coordinate starts being negative. The cosine is negative in this quadrant, only the sine is positive. So off we go. It's just a reflection of this point here. You see this point and this point are sort of the same spot on the unit circle, but the x-coordinate's negative, and I just can keep going here. And this is with different rotation angles, different special angles. And then finally the cos and sine of 180, left 1, and I haven't went up or down at all, and I keep going, keep going. X coordinate's negative, y coordinate is negative. The related acute angle is 45 for this one, and so the x and y coordinates are the same. Notice only the tangent's positive because I go sine divided by cos and I get tangent to be positive. Oops, 2. Square root of 3 over 2. Then for 270, it's not going left or right at all, so the cos of 270 is 0. The sine of 270 is negative 1, and keep going, keep going. And in this quadrant, the x is positive. I can see I'm going to the right and down, so cosine is positive. Sine's negative. And just keep going, same values. These are all reflections. Notice from here to here, well, it's got the same x value, but the y value is opposite. Same x value, y value, opposite. And so, in fact, some students, when they're learning their trig ratios and trig special angles, they just remember this picture. This is their favorite way. This is pretty tough, but where it fits in with today's stuff, if I just follow the x coordinate, this is rotation angle. The input is the angle, the output is the x coordinate. The x coordinate is the cosine. It goes from 1 to 0 to negative 1. From 1 to 0 to negative 1 at 180. This is 180 here then, right? This is 90. And then back up to 0, and then up to 1 by the time it gets all the way around. And in fact, there's a couple of links on this one. You'll be able to play with this in class. If I got this already, I think I do. Yeah, here it is here. This one, and I'm going to replay it. There's the rotation angle. It's going pretty fast. And then down here shows the graph. This is sine, so it's actually after the y coordinate. 0, 90, 180, 270, 360. See that? 0, 90, 180, 270, 360. These angles are measured in a different value, but you can see this should be 0. That's 90, 180, and 270. These are called radians, by the way, and it's just a different way to measure angles. Another way is using what's called the Geometers Sketchpad. So the Geometers Sketchpad here, notice that I'm going to put this point back to 0, and I'm going to put this point back to 0 where it belongs. This will fade in a second because that's what this does. So this angle, it's going to trace out the y coordinate, which is the sine. Remember, y is sine, as this value here starts spinning around the circle. We're interested in the y coordinate. So when I press animate, see, it's just went that little angle, and that's this little input is the angle. The output is the y coordinate for sine. If I had the cosine, it would be the x coordinate. Now if I keep going, see there, it's almost up to 90 degrees. This must be 90 degrees that's gone by, and it's almost up to 1 unit. Comes back down. There's 180 over 180. Now the y coordinate is negative, and it keeps going. Now this one sort of goes back and forth. It doesn't keep going this way like we're used to, but it's a pretty neat thing, and you can play with that in class at some point if you like. Back to the note. We could also use the graphing calculators to do this. So example 1, fire up a graphing calculator, and it asks us to use certain window values. Come on. There we go. Whatever you see on your screen, you can just press window, and notice I've already entered mine, so it matches, and so you'll get this sort of grid. And then you press y equals, and this one's got cos in here. I'm going to put sine in first because that's the first graph. Sine x. And if I press graph, then it's going to get the familiar shape. Every 30 degrees is an important point, and I get that familiar shape. Every 30 is an important point. Goes from 0 to 1 to 0 to negative 1. Oops, that was pretty bad. Oh well, you can do better. And so on. That's 1. It's 90. And then it says to use the trace or table feature. Now I'll show you what I mean here. So if I hit trace on my graphing calculator, then that's when I get to be the spider on there. And if I hit, for instance, 0, it'll jump me to that spot. I know this is 0. What's interesting is when we get to these values that we know exactly, like I put in 30, well, that's 0.5. Well, that's the same as a half, isn't it? But these ones that have square roots in them, what does it look like? So if I put in 45, that was 44, I'm going to put in 45, and it jumps to 0.71 about. And so on. I can put in all these values using trace. It says I could use the table feature. Now, the table feature is just second function table, but I want to set it up first. So I'm going to hit second window, and then it'll ask me where I'd like to start at 0 and how much I'd like to go up by. Notice that if I go up by 30, I'm going to miss the 45. So I could go up by 15, and it's already there for me. Set this auto and hit second function table, and then it'll give me these all these values. So I can just copy them in here. That's 0.87. That's 1, just like I expected. 120, if I go scroll down here a little bit, 120 was 0.87. And I'll let you decide whether the table function is easier or the trace function is easier. And 150 is 0.5. 180 is 0, right? It should be 0. 210 was negative 0.5. Finally, we get in the negatives, and so on, right? And this is this value, or this graph rather, done on the graphing calculator. Do the cosine, and you should get those values. I'll let you mess around with that, and then now you can get back to the homework. The homework should be short because most of the exercise was done in class today.